Open your favorite news app, and you're bound to see the headlines. Artificial intelligence is taking over the world. Super intelligent algorithms are coming for your job. It is easy to get swept up in the panic, but to cut through the noise, we need to ask a grounded question. What kinds of artificial intelligence are actually running on our servers right now? We often group AI by the underlying code, things like machine learning or deep neural networks. Today, we are putting those technical labels aside to look at a different framework, classifying AI purely by capability. By capability, we mean a direct measurement of what an artificial system can physically and intellectually accomplish when stacked up directly against the human mind. At the core of the current hype is a specific pattern of perception. When we see a system write an original poem or pass a bar exam, we tend to attribute it with self-aware intelligence, a reaction that often overlooks the distinction between sophisticated output and true understanding. Without a clear way to measure what these tools can actually do, we lose sight of their strict limitations. To understand where the technology actually stands, we have to divide it into three distinct tiers. The first and lowest tier on the capability spectrum is artificial narrow intelligence, frequently called weak AI. An ANI system is built for exactly one specific task. It excels in its lane, but it is completely incapable of thinking outside its original training parameters or applying what it knows to an unrelated problem. Here is the most crucial fact to remember about our current technological landscape. Every single artificial intelligence system that exists today, no matter how sophisticated it appears, is strictly narrow. You interact with narrow AI constantly. When you speak into your phone and ask a virtual assistant like Siri to set a timer or check the weather, you are triggering a highly constrained, specialized script. We see the exact same narrow capability in systems designed for immense calculations. Programs like IBM's Deep Blue can calculate millions of chess positions a second to defeat a grandmaster, but that same multi-million-dollar machine cannot play a simple game of checkers. Even when algorithms navigate dynamic, physical environments, like the sensor arrays guiding self-driving cars down a busy street, they are still executing highly specialized routines. No matter how convincingly a modern chatbot converses with you about philosophy, it doesn't know how to balance a budget or steer a vehicle. It is utterly incapable of performing any tasks outside its explicit programming. That brings us to the second tier, artificial general intelligence, often referred to by researchers as strong AI. AGI is defined as a machine possessing true human-level intelligence. An AGI system would be able to reason, adapt, and seamlessly transfer knowledge from one domain to an entirely different one, just like a person. Imagine a single model that could diagnose a rare condition by morning, architect complex software in the afternoon, and compose a symphony by evening, all without needing separate, specialized subprograms. AGI has not yet been built. No company possesses it, and it remains the ultimate, unrealized goal of current artificial intelligence research. The final tier on the spectrum is artificial superintelligence, or ASI. If AGI is human-level, ASI represents an intellect vastly beyond human capabilities. It would outperform the brightest human minds in practically every conceivable scientific, social, and engineering discipline. Many researchers theorize that once we achieve general intelligence, we will trigger an intelligence explosion. A human-level system could rewrite its own code to become smarter, rapidly upgrading itself until it achieves superintelligence. An ASI could solve problems millions of times faster than us, unlocking new branches of physics or curing complex diseases. But it also introduces severe risks, primarily the challenge of alignment, ensuring a vastly superior entity remains safely controlled and its goals match human survival. To clearly see where we stand, this table maps the three tiers. Narrow AI exists today, highly capable at specialized tasks. General AI possesses human-level intelligence across multiple domains, but does not exist today. Super AI, vastly beyond our capabilities, is entirely theoretical. By filtering the daily flood of news through this specific capability matrix, you have a reliable way to measure true technological progress against sensationalist claims. To recap our current historical placement, we live entirely within the era of specialized, narrow AI. We are actively striving for AGI, and superintelligence remains purely hypothetical. Internalizing this timeline makes you an informed consumer. When you know the boundaries of current technology, you can easily separate the tools you use today from tomorrow's science fiction. The next time you see a tech headline claiming a computer has gained sentience, you can test that claim against the strict boundary between narrow and general intelligence. But knowing what these broad categories are is only half the picture. We also need to understand the underlying mechanical processes of how these narrow systems acquire their specific skills. In our next video, we are looking under the hood at the training data pipelines, pattern recognition algorithms, and the stark reality of machine logic. Once you grasp the strict capability limits of modern algorithms, you quickly realize they don't think like human beings at all. We will explore exactly how they learn next time.